Let's balance some more chemical equations. Let's look at this reaction. Sodium hydroxide, this is solid, plus H3PO4 phosphoric acid, aqueous, reacts to make sodium phosphate, Na3PO4 aqueous, plus H2O, this is a liquid. So I've included these notations that are for solid and liquid, and the aqueous means that it's dissolved in water. And so sodium hydroxide plus phosphoric acid makes sodium phosphate plus water. It takes lots of words to write that out. By using our chemical symbols, our chemical formulas, we can write that in a much shorter, neater way. We're after balancing the equations. So we're trying to balance the number of each type of atom on both sides. So we just start with one type of atom on the reactant side and see how it changes the product side. So let's look at the sodium and sodium hydroxide. I've got one sodium on the reactant side. Product side, I've got 3. So let's try putting a 3 in front of the sodium hydroxide. A little trick here, I could try to balance the oxygens, that's next in the sodium hydroxide. But also notice that here I've got a polyatomic ion, this PO4. And so let's try to keep, whenever you have a polyatomic ion and we can see it on both sides, let's just keep those as a single entity. Think of that as a single entity. And so the PO4 and the PO4 now balance on each side. So if I look back at this oxygen, I'm only going to be concerned with the oxygens in the sodium hydroxide. I've got 3 of those. And in the water on the right-hand side, I've only got 1. So I need to increase the number of oxygens on the product side. So I'm going to try a 3 in front of the water. Now let's see about our hydrogens. I've got 3 hydrogens from the sodium hydroxide, 3 from the phosphoric acid, so that's 6 hydrogens. And then if I look at my water, 3 times 2 are 6 hydrogens. So methinks we've got this guy balanced, but let's make sure. 3 sodiums. Now I'm counting up the atoms on the reactant side. So 3 oxygens from the sodium hydroxide, and if I add 4 from the phosphoric acid, that gives me 7 oxygens. Then I add up my hydrogens, 3 hydrogens from the sodium hydroxide, 3 from the phosphoric acid, that's 6 hydrogens, and I've got 1 phosphorus atom on the reactant side. Product side, once again, 3 sodiums, I've got 1 phosphorus, and if I look at the oxygens, I got 4 from the phosphoric acid and 3 from the water, so that's 7 oxygens. And I add up my hydrogens, and I got 3 times 2 is 6 in the water, and voila, everything is balanced. This is a type of reaction. You'll come to learn that sodium hydroxide is a base, phosphoric acid is an acid, so this is an acid-base reaction or a neutralization reaction. Let's do this reaction. Let's take iron, that's a solid, plus oxygen, that's a gas, to make Fe2O3. What we're doing is we're making rust. So we've got solid iron, molecular oxygen on the right-hand side, I've got iron 3 oxide on the product side. Remember, oxygen is -2. 3 times -2 is -6. I've got 2 irons. They have to add up to +6. So each iron has to be +3. And hence its stock nomenclature name is iron 3 oxide. So let's balance our atoms. 1 iron on the left at the moment, the reactant side, 2 on the right. So I need more irons on the reactant side. So we're going to change the coefficient. You can only change the coefficient, not the subscript. So I've got 2 irons. And now I've got 2 oxygens on the reactant side. I've got 3 on the product side. So I don't have enough oxygens on the reactant side. So how am I going to balance this? Well, a little trick. I say I've got 2 oxygens on the left, 3 on the right. I need to get to where they're going to balance. I could put a 2 there, but then I'm not going to be, I've still got some, that's not going to balance right off. So a lot of times when I see 2 and 3, I'm just going to balance it like this, put a 3 in front. And so now I've got 3 times 2 or 6 oxygens on the reactant side. I've only got 3 oxygens on the right. I'm putting a 2 there. I'll balance the oxygens. I've got 6 oxygens on the product side. But now I've bumped up the number of irons. I've got 4 irons on the product side. I've only got 2 on the reactant side. So let's stretch through that 2 and wind up with 4. Put a 4 as a coefficient in front. So now I got 4 iron, 3 times 2 are 6 oxygens on the reactant side, and 2 times 2 is 4 iron on the product side, and 2 times 3 oxygens are 6 oxygens. The number of each type of atom is the same on both sides, follows the law of conservation of matter, and we have a balanced chemical equation.